Okay, day 5, and this is just, there's only one day of day 5. It's the law of sine. So I know you guys did some of this in geometry. It's basically, you use this when you don't have a right triangle, but you still want to find some missing sides and angles. So our learning target is to find missing triangle side lengths and angle lengths using the law of sines. Notice this first triangle is not a right triangle, so we couldn't just use sine, cosine, or tangent. We have to do a little bit more if we wanted to find the missing sides and angles. And well, in this one, I guess the missing angle, it actually would be even easier, just 180 minus this 120, so that's going to be 60 degrees in there. But we're trying to find the area anyway, so we're not really trying to find all the sides. We don't ever need to know what this side is, but the law of sines could help us. So if you remember, the basic formula for a triangle is 1/2 base times height. Okay, so you think 1/2 base times height. And the problem with this guy, if I look at when I got my 1/2, and I could think of this as my base, 30 as my base. Well, I don't really know what the height is, but if I drop down a height here, call that h. If I drop down a height, well, I could use sine. So sine is opposite over hypotenuse. So sine 60 equals opposite over hypotenuse. If I multiply 23 over, I've got what the height is. So I could put in here 23 sine 60. And that it really is where we had a different formula. 1/2 base times height is what this is based off of. But we had a different formula in there that said area equals, and it was AB sine of C over 2. Well, that's exactly what this is. Here's the half is down here. AB sine of C means you got an angle, and it's the included angle of two sides. So I knew these two sides, I knew the included angle. So 30, 23 sine of 60. That's where it came from. So maybe you memorize this, but if you didn't memorize it, you could just analytically find it. So this one, when I put in the calculator, well, half of 30, I could just say is 15. So 15 times 23 times sine of 60, it is 298.77. So again, over here, if I want to use this formula, area equals, you can say 1/2, or I'll just say divided by 2. So AB sine of C. Well, I have to have the included angle between two sides. Well, here's two sides. There's the included angle. That works perfect. So AB, so it'd be 20 times 50, and then sine 25, all divided by 2. Again, half of 20 is 10. So it's going to be 500 sine of 25. So the area is 211.31. Okay, so down here, we're going to try to develop the law of sines. I know you probably remember seeing this, but just so you know where it comes from. Kind of the same idea up here, finding that height, using an angle to find that height. This guy here, if I'm trying to find this height, I could say that the sine of this A, so sine of A, would equal opposite over hypotenuse, so h over c. And I could also say that this c over here, the sine of c would equal opposite over hypotenuse, so h over a. Okay, multiply the c over, so c sine of a would equal h, but also a sine of c would also equal h. I solve for h in both of these. Since they both equal h, I can set them equal. So c sine of a equals a sine of c. And then if I divide the a to this side, divide the c to that side, I've got sine of a over little a equals sine of c over little c. And as you can probably imagine, I could do the same thing with a different pair. I used angle A and angle C. Well, if I use angle B and angle C, I'm going to get that this equals sine of B over little b. Different order, but same thing as up here. Okay, so we're going to be using that along the way here. Just using these ratios. Now you're going to cover up one of them. You only need one proportion. So you're going to use any pair of two of these to solve. So in this triangle here, let A, B, and C, respectively, so those are little letters. The sides are always called little letters. The angles are always capital letters. Represent the lengths of the sides opposite big A, big C are angles, then this is true. So to be able to use this, though, to be able to work, I got two lines on here. You need to know two angles and any side. And because if you know two angles, you actually know three angles. Because you see, the sum of the angles in a triangle equal 180. So if you know two, you know the third. Or if you know two sides and the included and the angle opposite one of them. So basically, in the end, you have to know an angle and its opposite side to be able to use this. Okay, so if you're looking at a triangle and you don't have an angle, the measure you know, and the opposite side that you know the length of, you can't use law of sines, and that's going to be a law of cosines we're going to do tomorrow. So looking at this guy, looking at these guys, I have an angle and its opposite side. That's good. That means I can use it. Now there's actually three situations, though. We got to look at, remember doing triangle proof, so angle, side, angle, and those sort of things. If it's angle, side, angle, or angle, angle, side, then, basically we're just going to have one answer we have to worry about. It's whenever we have side, side, angle, and notice I have side, side, angle, not angle, side, side, because that would spell cuss words, so we don't want to do that. So side, we always say side, side, angle. If we have that, there's actually a couple answers going to come out, so we'll talk about that when we get down there. But if you're trying to find, so I'm trying to find this, side, it would be, I have to know the angle opposite that first off, but I also have to know one pair of angle and its opposite side. So this is the key right here. I know one. I know an angle and its opposite side. So that means sine of 39 over 40. I'm going to write that down first, and then write down what I want. So what I want is x. I need to know this angle. Well, since I have two angles, I can find the third one. That's 109. Sine of 109. So you have to know one pair, and then the other one, just one missing part. So here, with these guys, I had to know the angle or the side to find the last thing. So here, do cross products, or think of it as a proportion. So this cross product would be 40 sine 109. That's going to equal x times sine 39. So I'm going to divide by sine 39 to x by itself. Okay, so put that in the calculator. You're going to take 40 sine 109 divided by sine 39. That answer is your answer. That's x by itself. And that one, make sure you're in degree mode. Make sure you're doing degrees. You should get 60.1. Over here, see, I need to have an angle and its opposite side. So these two right here I know. So I'm going to write that proportion first. So sine 70 over 8. And then the ones I want is here. Well, I know one of them, so I just need to find x, so sine of x over 4. And what happens here when I cross multiply and divide, I'll take 4 times sine 70, and that equals 8 sine of x. When I divide by 8, that equals sine x. Not x, but sine x. So at some point I'm going to have to do inverse sine of all of this. I'll say inverse sine of all of this, so that's going to just equal x. So if I do inverse sine of this ratio, I got my answer. So plug in the calculator, you got basically 28 degrees if you plug in the calculator correct, which I would just do 4 sine 70, make sure you in parentheses, divided by 8, hit enter, and then do inverse sine of that. That's, if you probably could do it all with parentheses. I don't do that. I'm not going to try to do too many things all at once with parentheses. Now the ambiguous case here, look at these two triangles. I have 35 degrees, 8 and 6, and here I have 35 degrees, 8 and 6. But they're two totally different triangles. But if I use law of sines think there's one. And when you do it in the calculator, it's always going to give you the acute angle. So if I'm trying to find C, it's going to tell me the acute angle. But here's C with an obtuse angle. And what it is, this side right here, if I swing it down this way, 6 units, it's going to meet right there, which is what this is. It's not quite drawn to scale. If I swing this way, swing it down over here, it makes two different triangles here. So anytime this could swing back and forth, and the way you do it, we don't really need to check this, but if you could find that hypotenuse, if this side is longer than the hypotenuse, that means you have two answers. If this side is actually shorter than the hypotenuse, that means this triangle doesn't exist. They give you the word problems and not a picture, and things don't work out. It's possible to not have a triangle. This isn't long enough to make it. Now this one here happens to be longer than the hypotenuse, or longer than the height. Instead of hypotenuse, longer than the height. So when this swings down, it could actually touch it in two different places and create two different triangles. So if you just solve it, it's going to give you the acute angle. So let's just solve it, the acute angle wise. So here's the pair that I know. So sine 35 over 6 equals sine of c over 8. Again, when I type in the calculator, it's going to give me an acute angle, which is this one. So you always find the acute one. You got to check to see if there's an obtuse one too. So if I solve this, it'd be 8 sine 35, and then that equals 6 sine c, so I'm going to divide by 6 and equals sine c. And then eventually do the inverse sine of all of this. So this is just going to be angle c. Type in the calculator, you get 49.9. Okay, so that's this one here. It's not this angle. Sorry, my video froze. It's not this angle over here. It's that one. So if you look at this, if this is 6, that one's also 6, which means that these base angles are going to be congruent also. So if the opposite angles are congruent, and that's this way, then that means they're the same. So if this is 49.9, this is 49.9, we want to know what's this angle on this side. Okay, well, that's a straight angle. It's 180. So 180 minus 49.9 is what's left. This angle over here, what's left. So that would be 130.1. So that means C could equal 49.9, or it could equal 130.1.